Hello, I'm Kate Dalby of Inspiring Test Preparation in Vienna, Virginia. This question is from this year's TJ SIS Math question. That's for 2020. TJ meaning Thomas Jefferson High School of Science and Technology. Each year, TJ administers a test for applicants to its 9th grade class. And one of the questions is a math question that is allotted 30 minutes. Now, today's question will be posted below, so you can try it on your own. If you haven't tried the question yet, I would suggest you take a moment to review the question and give yourself a good 20-30 minutes to do it. The question does not require a calculator, but the calculations are pretty awful, and so I used a calculator in checking my work, but it can be done without a calculator. I would be surprised if TJ was worrying whether you rounded correctly. They didn't give any directions on how to round this problem. Now, the problem is, a popular road in California is famous for its steepness and turns. It has been filmed for many car chases. In 1920, the builder decreased the slope from 27% to 14% to fit a 12 to 15% highway requirement. What is the difference from the length of the old road and the new road if the height of the hill is 600 feet? What is the percent increase? So here we have a sketch. It's more or less to scale. There is a 600-foot hill. The first road, the old road, has a 27% incline. The new road, a 14% incline. And in my initial problem solving, I estimated about 100% increase in the length of the road. It looked, and that's partly based on the fact that you are going from 27 to 14, and that means a 13% difference, and 13 is to 14 is about 90 some odd percent, depending on how you do your calculations. So that was my initial calculation, was about a 90% increase, and I did not do the math when I was first calculating. I just wanted to make sure that my plan was in place so I could then go ahead and work out the numbers, which, as I mentioned before, are not very nice numbers. Now, we have the old road length, we have the new road length, and we need to find the difference, and then the difference over the old will give us our percent difference. Now, in order to calculate the length of the road, we first need to know its relative length, how it is relative to the 27% grade and the 14% grade. So I have a picture of a triangle with a 27 unit rise and 100 unit length. And when you take the Pythagorean theorem, which is a squared plus b squared is c squared, 27 squared plus 100 squared is about 104 squared. That is rounded up to the nearest unit. Now, on my second calculation, I have 14 squared plus 100 squared gets me approximately 101 squared. So the relative length is 104 units for the steeper road and 101 for the longer road. Now, that is not the length of the road. Those are just the relative proportions based on the 27% grade and the 14% grade. Now that we've figured out the proportions, and the proportions are, for the old road length, a 27 unit rise, 100 unit length, and a road length, a proportional length of 104. And in order to figure out the actual road length, you need to set up a proportion, and the proportion is rise is to road. So your rise of 27 is a road length of 104, as 600 feet is to x, and then you'll need to set up a cross multiply 27 times x, and you get 27 times x equals 600 times 104. Remember again, 104 is a rounding up, and x equals 2,311, and that value is also a rounded up value. So we've got a fair bit of rounding we're doing, but I don't think that they should be taking off for inexactitude on a question like this when they are only giving you 30 minutes and no calculator to do your calculations. So now we need to calculate, after we get the road length, this is the old road of 2,311 feet, and we can go ahead and put that down as 2,311 here on this board. That's feet. And then we'll go to our next set of calculations. Our next set of calculations, we want to take our rise of 14, and that's proportional to 101, and that is the same relationship as 600 feet is to, we'll call it y this time, just to keep it somewhat straight. We have 14y equals 600 times 101, and then we divide by 14, and when we do that, the value we get for y is 4,329. 4,329. Again, this value has been rounded up, as has the value of 101. So we go ahead and label our second road 4,329. Now, that's our second road, is 4,329. Now, the difference between these two amounts is 2018. I swear every time I do this problem I get a slightly different value, so it's probably because of my rounding errors. So our next step is to figure out what is the difference in the length. Well, we did that. That's 2018. So when we went from 2,311 and we increased by 2018, we got the new road length of 4,329. Now that value, we want to take the difference, and the difference of 2018 divided by the old length of 2,311 would be 87%. Now, what value would we get if we just found the difference in the slopes? If we took the 27% and we subtracted 14%, we would get a difference of 13%. Now, 13% as a percent of 14 should get us a value fairly close to the difference in the road when we use the road lengths. That is 93 when you round up, 93%. Now this is a change in the slope, but it should be, I would feel closer, I would feel better if the values were closer. But again, I think the difference has to do with rounding errors. Any comments people want to make about my calculations, have at it. I do not feel super confident about this, but I think the general approach is consistent, and I think that my math skills are probably about the same as most of the 8th graders who get into TJ. So, well, some of them are better than I am, but this will give you an idea of one way to approach it. Obviously, if you had a trig table, you could do this a little bit more quickly also. If you had a calculator, you could do it more quickly. When I did this by hand, and I did go ahead and originally do the problem by hand in order to give myself a sense of what the students were encountering, it took me probably about 25 minutes, and that would give me about 5 minutes to type up an explanation. So kind of tight with time, but this is my solution, and comment away if you have different insight that might be helpful to any viewers. I'd love to see your insights in the comments below. Please like the video if you like it. If you have any questions, you're welcome to call me at 703-203-5796, and look forward to the next time we meet up. Thank you.